Okay, so this is 6.6, and I just labeled this curve fitting. So what we did with our tidal sine wave project, you guys collected data over a 3-day period, and the idea was to get a function, a sine wave, that you could use to model the swing of the tides through the rest of the month, really. Okay, so what you did is on that back page of it, after you collected your data, you had your XY data, and you graphed it, you found the function by hand. And 3 out of 4 parts were pretty easy and obvious what to do. Like finding the amplitude, I think is pretty easy. Right? The amplitude is just you took the difference between the high and low tide, even if it was a negative, and then you split it. So you're splitting the difference. That's the amplitude. And then you found the vertical shift by taking the average of the high and low tide. I think I said consecutive. Oh no, that was for the period. So high and low tide, the highest and lowest, you added them up and divided by 2. That gave you D. So A and D were easy to find. And then B was a little bit harder. You had to take the consecutive high tides, look at the X data, the time that went with that, subtract them, and that gave you an approximate period. What did you find the period to be in each case? So we might talk about this a little bit. About 12 hours. So if you go and look at tide charts, you go to the beach and you get a little, they're made out of cardstock, but they just will give you the tide for that month or whatever. You'll see that it's about 12-hour swing between tides. So if you show up at 7 in the morning at the beach and it's low tide and you go looking around in all the tide pools, you can figure that then again at 7 o'clock at night will be, the next tide swing, low tide days. It may not be the same height, it may not be as low, but that's the tide swing. So those 3 parts, getting A, D, and E were easy, and then there was a little formula, magic formula I gave you there for finding the horizontal shift. That's because that can be a little more difficult finding that. So it's doable to find it by hand, but what I want to show you today is that built into your calculator and on any mathematical software, even the free software we've used like Desmos or GeoGebra, you can create a table of values and do a regression equation, it's called. And a regression equation is simply an equation of best fit for your data. Okay? So the only thing you really have to know as a mathematician is what regression equation works best for your data, because you're going to have a whole bunch of different choices, and you kind of have to have an idea in your mind in terms of what function is the one of best fit when you go to do it, because it could kick out a regression equation that might work for your data. It really doesn't make sense in the long run. Okay, so what I have here are a couple of different problems. We're going to do them using what's called sine regression on your calculator. It says the hours of daylight on the 15th of each month in New York are given. So hours of daylight is periodic as you go through the year. Calculate the sinusoidal, that's just a fancy name for sine function model or sine graph. And use the model to estimate the number of hours of daylight on September 30th. So what we're going to do is call the month the X data and the hours of daylight Y. We're going to label it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So those are the 12 months of the year. We'll just label them, give them numerical values, okay? So we can get a function to model it. So that would mean if I want to plug in the 30th day of September, that would fall right in here between September and October, and we will call that data point 9.5. So 15. So what's happening is that the 15th of the day, the 15th of each month is when the hours of daylight is recorded, and what we're doing is going half of a month beyond that 15. So 9.5 is what we'll plug in. You could decide on a different labeling scheme for this. You just have to adjust appropriately here. Hours of daylight. This is hours of daylight on that middle of the month day, and you can see that it is periodic. In the winter, they're shorter days, and in the summer, longer days, and it goes back to shorter days as we get back to December. So you can see kind of periodic pattern there. So what we're going to do on your calculator, I've written it up here on the board. We're going to go to the Stat button and then hit Enter for the Edit button, and we're going to put the X data in list 1 and the Y data in list 2. The Stat button is, I'm going to pull it up right now. It's right there below delete, so in the middle column, you'll hit stat. Well, one other thing before you move on, you might want to make sure that you're in the correct mode. So just check and make sure you're in radian mode. So our input and time will be a real number in radian. And then go ahead and hit the stat button. And then you just hit enter. So stat and enter. You might want to, if you want to write that down, but I'm recording it here. So stat button, and then enter. So see, I went second. Actually, I could leave this up too. But I went to second, and then the quit button or mode button, and then I went to mode to make sure I was in radian mode, and then stat, and then enter. That's my keystroke history so far. So you'll see that I have stuff in my list 1 and list 2. If you're in statistics, you might have stuff in your list 1 and list 2. What you're going to do is highlight list 1, hit the clear button, and then enter, and that will clear list 1. I think that's a wise thing to do because we will be in overwrite mode, and so if I have less data points, it will leave the rest of them in there. We don't want that. So I'm going to go to list 2, hit clear, and then enter. And so now my lists are clear. I have list 1 and list 2. Is anybody missing a list 1 and list 2? Sometimes they will get deleted if you all have a list 1 and list 2. Okay, it wouldn't matter if I put it in list 1 and list 3 or list 3 and list 1. It doesn't really matter. I just need to pay attention to where my X data is and where my Y data is. That's all. So I'm going to enter in 1, hit enter, and then 2, enter. I'm just entering the data into list 1. So go ahead and do that now. Enter in the values 1 through 12. There it is. I entered in the values 1 through 12. And then for list 2, I'm going to enter in all those different values that record the amount of daylight we have. We'll do that next. All right, so we're going to enter in 9.58. Hit enter, and then 10.67. 11.9. 13.3. Just kind of double check that they're lining up with the right month. And 14.43. And then 15.07. And then 14.8. And then 13.8. 12.48. 11.15. 9.9. And 9.27. There it is, 12 values. So list 1 and list 2 are all filled out. I have my X and my Y data. So here we go. We're going to find the equation, the sine equation. A couple of you are still typing in the values. I'll let you do that first. There it is. You'll notice that they match up. They both have the same number. If you get a dimension mismatch error, that means you skipped a number or something, or added one in, or whatever. Okay, so what we're going to do next, I have it up on the board. We click on the button Stat, but this time instead of going to Edit, you're going to right arrow and go to Calculate. Stat and then Calculate. And then, no, not one variable stats, try again. Stat, Calculate. And then what we want to select is the sine regression. It'll look like, it's abbreviated, SIN and then REG. I think it's down here at letter C. There it is. So down at letter C is the sign regression. Select that. Then for those of you who are in classic mode, there are 3 entries that you'll do. So if you're in classic mode, if you have the newer calculator like mine, the screen will look like mine, but you'll have sign reg, you're going to enter in list 1, comma, list 2, comma, and then y1. And I'll show you how to get to y1. But if you're in the classic mode, that's what it'll look like. Got 3 entries. What I'm going to do is see my X list. It's asking me what list I want to use for my X variables, and I just put them in list 1. That's what I mean. If you had put your X variables in list 5, you could have just tell the calculator. You got to pay attention to where they're located. My Y list is list 2. Period. I'm just going to let it fill the screen with the graph, and it does it. And then, so those of you in classic mode, once you select sign reg, it'll be list 1, which is you just hit second, and then the number 1 key. And then comma, the comma is in the second column, it's right here. And then you'll hit second, number 2, and that will pull up list 2. And then what a nice feature here is to go ahead and have the calculator store the regression equation in Y1 so you don't have to type it out. And you'll see why you don't really want to type it out when it kicks out the function. It's using an algorithm to kick it out, and it carries the decimal, like fills the screen with the numbers past the decimal. So it's kind of a pain to type it out that way. You could definitely just cut it off at the nearest 100th. It would be fine. But what I'm going to do is the bottom commands there. See where it says VARS and then arrow Y, VR. That's variables, Y variables. We're going to select function Y1 in that order. So variables key is right here in the second column over from the right. So you're going to go to variables. You're going to go right arrow to Y variables, then hit enter for function, and then enter for Y1. And so if you're in the classic mode, you'll then have to close off your parentheses after that 3rd entry. So you have list 1 is your X data, list 2 is your Y data, and Y1 is where we want it to store that equation when it comes up with it. So yes.
Can you show how to put Y1?
Yes. So Y1, you're going to go, and I've written it up here in blue, if you can see that. You hit variables. So hit the variables key first. And then you're going to right arrow to Y variables. And then you're going to select function. Okay? And then hit enter, and it will pull up Y1. Okay? So this is doing the equivalent of what you guys did by hand. It's going to come up with an equation right now. So when I go down to calculate, I'll hit enter. It's thinking, and there it is. So it's coming up with an equation. You can see here, what's my amplitude in this case? Can you read it off of there?
2, 3.
Yeah, about 2 point something, right? 2.87. So the amplitude is 2.87. My B value is 0.51. My C value, what does C represent? Sort of, yeah, but look at how they have it written out. So it's actually C divided by B would be my horizontal, because I factor out the B. But yeah, it's related to the horizontal shift, you're right, negative 1.59 about. And then D, remember what D is? That's the vertical shift of 12.12. Which, that makes sense because I was talking about hours of daylight, so it's, you know, it's got a kind of a midline of 12 hours. So it goes above that to about 15.07, I think, and then below it to 9 point something, right? So that vertical shift makes sense to me. So you would just, by hand, plug each of these A, B, C, and D into the equation, and there you're done. Okay? As easy as that. That's the equivalent of what you just did in your little project. What's cool about this is if you go to Y equals, is it will have typed it all out for you. Do you know why there's an arrow over here?
Because there's more stuff.
There's more stuff here. You know, they've taken it, they've basically filled the screen. But if you keep going right arrow, you'll see there's the B, the 0.50, 0.51024, blah, 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 blah. So there it is. So that's kind of nice. If you forget to do that, no big deal. Just round it to the nearest hundredth and plug it in yourself. It's not a big deal. But I'm all ready now to graph it, right? I got y equals. Let's go to window. And what do you think would be a good window setting for this daylight hours thing here?
12, no, 13.
No, but for X-Men, what is X represented by? Months. So maybe, should I start at 0?
0, yeah.
And then X max, maybe 12. And then what about X scale? Yeah, maybe 1's probably good, huh? And what do you think for Y min? What should I make my Y min? Remember my midline, my D was 12. How far below that do you think I should go? What was the lowest daylight hours? About 9? Do you think, is 9 going to include all of it? Is it 9? It was a little over 9?
Yeah.
Okay, so maybe we'll do 9, and then Y max, 16. Is that going to be enough? And then scale by 1s. Okay. And then we would just hit graph. So what is this actually showing us? Yeah, here. Yeah. It's kind of like one little portion of a cosine or sine curve. It's showing 1 year, so as you go through the years, you'd see it come back up again. It's going to keep going up, ranging between the same values approximately. So there it is. What if I want to plug in 9.5?
Do that.
You remember that? So you could plug it. You could, yeah, you could do second trace. You could get, or just trace, or second trace to calculate it. You could actually even trace on here. So we wanted x equal to 9.5. We could go like this. Or we could try the value feature, yeah.
Can we just make another line?
What?
Make another line.
You could. We'll do that too. That's a good way to do it. Find the intersection. So that it's going to be around 11.86. It's going to be the output. Another way to do this would be to try the second calculate. Sometimes it'll give you grief. It'll let's see if it'll do it this time. X equals
Grief?
yeah. Sometimes it will. If it's here it's not like right now. So this is a value. It's actually second trace and then value. And we want a value of, was it 9.5? You plug in 9.5 and hit enter. There it is. So it gave me about 11.8. If you don't get the right graph on it, it might, or if you don't have the right window setting on there, it might give you it will give you a message saying that it can't find, using the algorithm that's built in, it can't find the output with the window you've given it. So, but there it is, about 11.8. And then what Nick was suggesting, you could go to y equals and put in the line, well, this is an x equals line though. You do that if you were going backwards. If I told you, okay, what month am I in if I have only 10 hours of daylight? Then you would put in the horizontal line. I don't know if that's what you're talking about. But yeah, you're right. That's if I gave you the y value. The problem with the x value is it's a vertical line, and so it's not a function. This is a function graphing calculator, so the intersect isn't going to work that way. That's about it. I have this second example on here. So what did we get? We got 11.8. So you go back here. Could you guys tell me what the function is, just so we write up here to the nearest hundredth? It was y equals, what was the first value? 2.86? 7, okay. And then it was sine. And I think it was 0.51 or something like that. So in parentheses was it positive 0.51. X minus 7.51, 9, okay, 1.59, and then plus, I think it was 12.12. So there it is. I mean, that's pretty easy to do. X list, Y list, hit sine regression, and it does what you just did by hand pretty quickly. And then we plug in our value. So if we want Y of 9.5, it gave us about 11.8 hours. So that's predicting about how many hours of daylight we would have on the 30th of September that year. Yeah, there's a little variation from year to year, but it's essentially periodic. It's like your tide thing. There's a little variation. It wasn't, the amplitude wasn't exactly the same all the way around. It was a little bit, it could go a little higher, a little lower. Yeah.
This might be a dumb question, but how did you get
2.87, that was the A number. Is that what it said on there?
Oh, yeah.
I think that was the first number on there. So it lists the A, B, C, and D for you, and just plug them into the form of the equation they had listed on the top. Which of course is, that's why I was showing you the function for sine and cosine in this form. We have to of course factor it out if we're going to graph it by hand. But this seems to be the form they have it in. So, we can do the same thing for number 2 here. You go ahead and try it if you want, average temperatures versus month. Why don't you go ahead and try it? I can write down the function so you can check. Why don't you try it right now, and then we'll do our last example. So take a moment here, see if you can enter in the data and get something that matches mine. So last one on here. This is a no calculator one. But I'm not going to do the phase shift. Okay, so I don't have the phase shift on here. So we're using this picture. It says the following diagram shows the movement of a piston as the crankshaft rotates counterclockwise. So it's rotating counterclockwise. Determine a sinusoidal function to model the position of the piston at different rotations of the crankshaft. So we don't want the piston to hit the crankshaft, so it's lifted up a little bit. If you look here, it's 4 units, whatever the units are, above the center of the crankshaft here. Then it goes up in its cycle to 7 units, and then it comes back down to 4, and then it's back down to just 1, and that gives me clearance here, apparently. And then back up to 4. So there's a full cycle. So we have y equals. Okay, we have y equals a sine. Let's just fill everything in that we know. I'm going to pull the b out. Okay, rather than writing it in the form that we just did the last 2 equations, I'm pulling the b out. Can you figure out the amplitude based on what you know about constructing sinusoidal functions with the tidal sine wave thing? What's the highest the piston hits? What's the lowest it hits? So what do we do to find A then if we know the highest and the lowest? I don't think the lowest was 4 though, it was 1 actually. What do we do on our tidal sine wave, do you remember? The mean is going to give me the vertical shift, easy. But A amplitude is going to be the difference divided by 2. So 7 minus 1 divided by 2, which gives me 3. You with me? Okay, the amplitude should be halfway in between. Halfway in between the lowest and highest. So actually it should land at, let's see, the amplitude is the distance, I should say, between the midline, which is 4, and the lowest, or the midline and the highest. So the distance from here to here is 3, and the distance from here to here is 3. So that's the amplitude. So amplitude is half the difference of the highest and lowest y value. That's it. Okay, that's on your little sheet there. That was the amplitude. How am I going to find B? What equation do I use to find B?
2 pi over
2. Okay, 2 pi over, in this case, the period. And what's the period according to this picture? Not pi, that's only half of a cycle. That's go up and then back to the middle. Yeah, it's 2 pi. So B equals 1. Good. So we've got A, we've got B. I told you there is no horizontal shift. So we could put C is not applicable, right? Then how do I find D?
Ooh, don't tell me. Don't tell me. Don't tell me.
You lose.
What was it?
Average, mean, yes. So it's equal to 7 plus 1 over 2, which is 4. So let's plug all this in, and we've got it. Y equals 3. Sine. B is 1. C is 0. Okay, so there it is. Plugging everything in. Let's clean it up.
Wait, why?
There it is. So, yeah, I'll have something like that on the review as well. So, this is equivalent to what you did in the title sine wave project. It's just I made up the values that are all part of the unit circle. And the reason I did that was so that the second part of it, what did I say to plug in? What am I asking you to plug in? Where's the position of the piston above the center of the crankshaft at a rotation of 11 pi over 6? So I'm asking you to plug in 11 pi over 6. So just before it gets to the end of one full cycle, one full period, what is the position of the piston? So we have 3 sine of 11 pi over 6 plus 4.
Why do you want to go? Oh, no. Wait.
In real life, we're not going to model this, as multiples of pi. It would be a decimal value. But I just constructed it that way. This would be a good estimate. So 11 pi over 6. What is sine of 11 pi over 6? Some unit circle math here. Sine of 11 pi over 6 is? Yep. And what's the sign on it? Negative. Good. So, final answer, this is negative 1.5 plus 4, or 2.5.
I know more.
Oh my God.